Hello YouTube creators and subscribers, I just wanted to thank you all for tuning into my video. To let all the viewers know what we're going to be going through is the Paleoproterozoic Eon. And this eon features a oxygen Holocaust that kills off all anaerobic life. There's also new formations of a supercontinent and some mountain ranges, among other multicellular life forms that have DNA. So, let's go ahead and progress into this chapter. So the Paleoproterozoic Eon. We're in this part of Earth's history right here, in this little blue area. And the time period is from 2,500 to 1,600 million years ago. It's the longest era of the Earth's geological history. Evidence suggests that the Earth's rotational rate during this era resulted in 24-hour days, implying a total of 450 days per year. Now, more free oxygen was produced during this time, which killed off a lot of anaerobic life forms. There was based off their metabolism, in which the forms needed to not require oxygen. So essentially, they did not require oxygen at that time. The oxygen could have created a worldwide holocaust for anaerobic life, as stated, and few forms of anaerobic life forms are on this right side pictured here. Now, most notoriously, crown node eukaryotes were created during this period. The oxygen holocaust started in this eon, which was about 2,000 million years ago. Before this time, there was almost no oxygen in the Earth's atmosphere. Cyanobacteria is responsible for higher levels of oxygen. Some life forms learn to detoxify and exploit oxygen. Certain life forms certainly did have the capability to detoxify from the oxygen levels and to use it in a way that's beneficial for their life. Now, hydrogen escaped into space, which became less available, and cyanobacteria were photosynthetic and had proteins inside them organized into electron transport chains. Cyanobacteria was able to split H2O into hydrogen and oxygen molecules. This helped create high levels of oxygen. Cyanobacteria converts light into energy. So with the photosynthetic creation of the cyanobacteria had the capability to bring about new life, but also destruction as well. The split hydrogen was grabbed and added onto carbon dioxide from the air to make organized and organic food chemicals such as sugars. Today, cyanobacteria grows on rocks, swimming pool surfaces, drinking fountains, shower curtains, and sand flats, or anywhere where there's light and water. Oxygen was a deadly poison to all early life. 90% of the world's commercial iron was created during this eon through the iron oxidizing bacteria. This would have helped form the vast quantities of ancient iron ore that existed on Earth. The Great Oxidation event, when the Earth's atmosphere and the shallow ocean experienced a rise in oxygen. So the Great Oxidation event was key in bringing about plant life, small type of land animals, and the likes. So emergence of eukaryotes. So crown node eukaryotes started to show up. Eukaryotes, they do contain a nucleus and chromosome as well as DNA. So photosynthesis had a relatively rapid impact on the environment as it set the stage for further evolution of eukaryotic cells. Eukaryotes were found to evolve a lot faster than prokaryotes. The increasing complexity may have been a response to both energy availability, such as oxygen, and the ability to extract it and turn it into mitochondria, which is DNA. Plastids provided eukaryotes with the ability to generate their own oxygen, benefiting those species, such as algae, and their ecosystem partners that they influenced, which were early animals, and fungi, which was influenced indirectly. So you could see the plastids, you could see the cellular form, and how it keeps the DNA inside of the eukaryote. And then the crown node eukaryote is pictured here, which has different structure, and life at this time on Earth was getting more complicated. So geological events, there's a lot, we're not going to go through them all, they're all listed here. And the earliest global scale continent, 2-continent collision belts developed, more mountains started to be built, and then you had a lot of land masses, and like I said, we're not going to go through them all, but we'll highlight some of the most interesting ones. So the Trans-Amazonian in South America, which is this piece of land, developed during that time. Emergence orogens, which was located in West Africa, was developed during that time. So those orogens developed were basically squished together through the tectonic plates, created mountains, created valleys, ridges, and this is one of those orogens. Limpopo Belt in southern Africa, which is this huge body of water and sort of flat looking landmass. Now, if you want to find out more about the Paleoproterozoic Eon, I'll leave links to the sources that I used in the description of the video. If you enjoyed what you saw, please like, comment, and subscribe. And you have a good afternoon or evening.